Welcome back, guys. In this video, we're going to learn how to factor. So we're going to give you examples and types of factoring. In this video, we're going to learn is when a equals 1, a doesn't equal 1, perfect trinomials, and difference of two squares.
All right, so the first type of factoring is when a is equal to 1. So a is the number in front of the x squared, and you can see in this example, x squared doesn't have a number in front of it, so you can assume there's a 1 there. So for this one, we can see we've got x squared plus 5x plus 6. But how do we break that down into multiple different brackets, right? Well, we need to find a number, or two numbers, that can add to 5 and multiply to 6. So we start by listing the factors of 6, right? So we could have, to make 6, we could have 1 times 6, 2 times 3, 3 times 2, or actually that's the same, so we don't need to do that. 1 times 6 or 2 times 3. So if you take 1 times 6 and you add these, it would be 7, so that's not going to work. But 2 times 3, if you add those, then it's going to equal 5, which means you can rewrite it as x plus 2 multiplied by x plus 3. And if you watch the expanding video, you can expand that back out to show that it is equal to that, but we're not going to do that right now for the sake of time. You can see that there isn't anything in here, but it means multiplication. So that's when a is equal to 1, but I'm going to do another example where there's some negatives in there, so I can tell you about that. All right, so this is another example when a is equal to 1, but you see we've got some negatives here. So what we do is, it is the same thing. We've got to find a number that adds to, there's 1 in front of here, so it's actually -1. We've got to find numbers that add to -1, but multiply to -12. So we're going to list the factors of what -12 could be. We've got, you could have 1 and -12, or -1 and 12, or 2 and -6, or -2 and 6, or 3 and -4, and -3 and 4. So you see, because it's negative, we've got to have a positive and a negative multiplied together to equal that. So now we've just got to find something here that can add to -1. So if you go through the list, you might notice that this is the only one that adds to -1 because 3 minus 4 is -1. So this is what we're going to do. And that means we can rewrite it as x plus 3 multiplied by x minus 4. So again, you can expand that out on your own if you want to confirm that that's how it works. But yeah, so that's how you do it with negatives. You've got to make sure to be careful because it's a lot different, obviously. Also, side note, if this number is positive and this number is negative, then there are two negative numbers because they have to add to a negative number. So that's about it. All right, so now we're going to look at equations where when a is not equal to 1. So here you can see there's a 4 in front of the x squared term, which means it's going to get a little bit more complicated, a little bit longer, but you should still be able to do it. So we've got 4 here and -5 here. Usually we would just find numbers that multiply to this number, but because we've got an a value, now I've got to multiply these two. So we're going to multiply 4 and -5, and that's going to give us -20. So now we've got to find two numbers that multiply to -20 and add to -1. So I am going to speed up the process this time. The numbers are going to be -5 and 4. So, right? You could go through the whole list, but I'm just speeding it up because I know the answer. So now, we can't write everything out quite yet. We've got to expand this. So we take the minus x and we split it up into the 4x and the minus 5x. All right, so now we've got the left side of the equation here and the right side, and we can common factor each side. So from these two terms, we can factor out 4x. And it'll leave us with x plus 1. And from these two terms, we can factor to -5. And that's going to also leave us with x plus 1, because because this goes from negative to positive because we're factoring out a negative number here. So now you can rewrite this thing as 4x minus 5 multiplied by x plus 1 because they're both multiplied by x plus 1, you can move it on the outside. And so this is your answer. And that's how you factor when a is not equal to 1. A little bit longer, but it's still doable. All right, so now we're gonna learn how to factor a perfect trinomial. So, as you can see, this has 3 terms, which means it is a trinomial. But to check if it's perfect, we look at the first and the third term. This one is a perfect square because it's just x squared, and 16 is also a perfect square because it's 4 squared. But to check if we can factor it, we've got to check if b is equal to 2 times the square root of ac. So we're going to take the square root of a and c, and then the square root of a is just x, and the square root of c is 4. So that will be 2 times 4x, which is 8x, and b is 8x, which means we can factor it. So next up, to factor the perfect trinomial, we're going to take the sign here, or we're going to put just left bracket and then this term, or the square root of this term, and then take this sign, which is plus, and then the square root of this term, which is 4, and then this is squared. So you can also factor that out, or expand that out if you want to see if that works, but that's it. So as long as b is equal to 2 then the square root of ac, then it's the square root of this plus the square root of this, or minus if this is a negative, which we will do in just a moment. All right, so for this one, we can see that x squared is a perfect square, 25 is a perfect square. So we're going to take 2 times the square root of ac. A is x, x squared, and c is 25. So that's going to equal to 2 times the square root of this term times the square root of this term, and this is 10x. Now, here we can see it is subtracting, but I miswrote it. Don't worry about that. Everybody makes mistakes. Now, you can see this is minus 10x, but even though it is negative, we can still make this work. Actually, I don't have to erase that. So, we can now say that this is equal to the square root of this term, but because this is minus, we're going to say minus here, and then the square root of this term, 5, and it's still squared. So this was equal to x minus 5 all squared. All right, so now we're going to do the last factoring method, dots, which stands for difference of 2 squares. So first of all, if you see something like this, you might think you can't factor it because it's not 3 pieces, but you actually can. And that's because the left side, or the left part is a square, and the right side is a square, and they're being subtracted. If they're being added, you can't do it, but if they're being subtracted, you can. As you can see with this formula, a squared minus b squared is equal to a plus b multiplied by a minus b. So that may be a bit hard to remember, but you're going to have to do it. So to factor this out, what we're going to do is we're going to get a squared, which is 4x squared. So we take the square root of that, and that's 2x. And then b squared is just 9, so the square root of that is 3. So we're going to do plus b. And then the next part is a minus b, so that's going to be 2x minus 3 for this one. And that's the factor form. You can expand that out if you want to double check, because if you're doing FOIL, the outside and the inside would cancel out because of the way it's written. The outside would be minus 6x and the inside would be 6x, which is why you don't see an x term in here, but you can still factor it.
Thanks for watching this video. Hope you liked it, and see you in the next one.